Sie und euch hier willkommen heißen zu dürfen bei uns im Goethe Finance Club. Wir sind eine studentische Initiative der Goethe-Uni und wir versuchen das Bindeglied zwischen der Theorie im Studium und der Praxis im Beruf herzustellen, zu sein und dann die Verbindung herzustellen. Und wir freuen uns, dass wir diese Veranstaltung zusammen mit euch organisieren dürfen. Und ja, jetzt sagt der Sebastian noch kurz was zu unserer Veranstaltung, dem Technology Lab.
Genau, das läuft bei uns hier unter dem Namen, also ich bin erstmal der Sebastian, ich bin im Goethe Finance Club der Vorstand für IT und mit meinem Kollegen Till, der hier vorne sitzt und gerade winkt, machen wir ab diesem Semester ein Technology Lab. Das ist ein Kurs, wo wir den Leuten, hauptsächlich Anfängern, beibringen, zu programmieren in Python, Datenbanken, mit Hilfe von Blended Learning, Moodle etc. pp. Wer von euch ist denn interessiert oder beziehungsweise kommt zum Technology Lab nächste Woche? Okay, perfekt, damit ich nur so einen kleinen Überblick habe. Genau, das war schon von meiner Seite. Also willkommen und ich freue mich auf einen schönen Abend mit euch und ich kann das Wort an Heiko übergeben von Brainbot.
Ja, hallo. Erste Frage, sprechen wir Deutsch oder Englisch heute? Are there some English speakers, only English speakers here?
Yes.
Two? Same as last time. Okay, then I think we can switch to English then. If that's okay for you. Well, thank you everyone who helped organizing this. Oliver, Finance Club, very good. Also PwC, they sponsored drinks and some food, very nice. Last meetup was a bit more technical. We really went into the details of smart contracts and stuff. Here in Frankfurt, we thought looking more at the business side of it might be more appropriate. But nonetheless, the question is, who of you has a technical background? Quite a few. And who's more from the business side? Okay.
You're also looking for the same.
Sleeping. There we go. So, yes. So I'm from Brambo Technologies. I brought some of my colleagues. Who's from Brainbot? Or close to it? Okay, quite a few. Very good. I want to briefly introduce Brainbot as we're organizing this meetup. So we happened to help a 19-year-old a few years ago to build Ethereum, and now our mission is to bring adoption to the system that has two sides. One is making it scale so that it can cope with adoption, and also to look at use cases that bring adoption to the platform. We're 21, and most of us are based in Mainz, around the corner. We only do blockchain, mostly public blockchain if possible. But the company is actually quite old. We've been doing search technology before that, and well, it's very nice to work with a passionate team. We're all very passionate about blockchain technology. That's a very good setup. Projects, you might have heard of the Raiden network. It's quite similar to the Bitcoin Lightning network. It tries to scale out token transfer capacity. Scalability is a big issue for blockchain systems. We develop Raidex, that's a decentralized exchange. Why are decentralized exchanges important? For decentralized exchanges, you probably heard about Bitfinex or Mt. Gox. They eventually get hacked and the tokens are lost. If they're decentralized, you're always there's no custodian issue because you always have control over your keys or over your tokens by owning the key. And Raidex is a specialized variant of decentralized exchanges which is based on Raiden and therefore also scalable and low latency. Can you hear me good in the background? Yes? Okay. Trustlines network is similar to Ripple, or the original Ripple idea, with Christopher. Christopher is going to present that later. Further, we're working with or for the Ethereum Foundation, helping them with some co-development of the Python Ethereum client. We're one of the founding members of the Enterprise Ethereum Alliance. Alex will talk about this later. And we're also one of the key tech partners of the Energy Web Foundation. Next to these projects, we're also offering our consulting services, doing workshops, some training, developing POCs, full D-apps, and also offer support. And we're hiring, so that's we're looking forward for people interested to work with us. Feel free to apply. It's quite fun to work on blockchain stuff. So that was one presentation. I need to switch presentation to this one. So today I want to give you some overview of what's the current state of Ethereum, what's happening. If you remember, why is there an Ethereum in the first place? Because we had Bitcoin. Vitalik Buterin at some point noticed that actually if you want to build a blockchain-based application, you always need to bootstrap a network. You need to build a system and then convince some miners to secure the blockchain by mining tokens. And he thought, well, what about if we have a more generalized blockchain where you can build applications on top? And while this was the initial idea, what emerges is an ecosystem of interoperable applications on top of these Ethereum EVM rails, which have synergies. And so whenever there's a new application on top of Ethereum, that's also beneficial to all other applications on the Ethereum ecosystem. So it's like kind of exponential growth. Whenever there's more users to one application, that's all beneficial to the other applications. And that's at the core of the system. The value proposition of Ethereum is synergy. And one of the main parts of that is a standard that we have in the Ethereum platform. It's called ERC20 token standard. This allows you to simply develop a smart contract which implements this standard, and then that token that's implemented by this smart contract can directly be used with any wallet, can be exchanged on any exchange, and works with most D-apps which accept ERC20 tokens for whatever functionality. And this standard has seen quite some adoption. If you look at CoinMarketCap, which is a website which lists blockchain-based applications or projects which have a token which has some value, then you can see that 75% in the top 20 list of these applications are built on Ethereum and especially use the ERC20 token standard. And that's why some in the ecosystem say this ERC20 token standard is the killer application that we've seen on Ethereum so far, because it was successfully used for many applications and especially for crowdfunding them. And I don't know how many of you followed that, but on the Ethereum platform, a lot of projects get built, and then if they see crowdfunding, these crowdfunding events, these token sales are often sold out within minutes, and these companies can raise 5 to 12 million. So we just had Gnosis this week, at the beginning of the week, they sold tokens, only 5% of the tokens, say it's like 5% of the company. In 20 minutes, they raised $12.5 million worth of Ether, and got a valuation of $300 million, which is probably appropriate for a project which is very successful, but always there's some risk involved, and it's a bit uncertain what the future brings. Fat Protocols is a term coined, I think, by Unisquare Ventures, one of their employees. A protocol is a standard like TCP/IP or SMTP for email, and for these standards, they don't capture value, but instead they're used by applications built on top, and these applications can be very successful, very valuable. In the blockchain space, that's different. If you have standards based or protocols based on blockchain technology, then they are built on financial rails, and they can capture value more easily because they can be tokenized, or access to their functionality can be controlled by tokens, which then can have some value. So say whenever there's a successful application on top of Ethereum, that not only makes this application valuable, but also the platform it runs on, right? And so whenever there's a successful application on top of Ethereum, that also makes Ethereum more valuable. And the same goes for protocols that we define on top of Ethereum. And therefore, a lot of the projects that we're currently seeing in the space, they're actually so-called protocols or protocol tokens. and I'm going to present some of them. We call these mostly D-apps, decentralized applications. What is a D-app? It's based on two components. It's based on a set of smart contracts on the Ethereum blockchain, and it usually comes with a user interface, which makes it easy to access it. And the user interface should be stored on some decentralized file system like IPFS, something that cannot easily be manipulated. And this together is called the app. So let's look at Melonport. Melonport is a platform aimed at, I think, hedge funds, which helps them to be more efficient when managing portfolios. Initially, I think digital asset portfolios, like everything that can be tokenized on Ethereum blockchain. Later, they're also looking or I think they're assuming that more real-world assets can be tokenized and represented on Ethereum blockchain. Actually, the guy who initiated it, Retro Tinkler, he was one of our interns earlier last year. Then we already mentioned that Gnosis, very successful token launch. They're doing prediction markets. A prediction market is basically a binary bet on a future outcome. Say if you have a good idea whether Deutsche Bank will be not bankrupt by the end of the year, then you could go to a prediction market and bet there according to your beliefs or whatever inside knowledge you have. There's another prediction market based on Ethereum that's called Augur, also a very interesting project. Something else, stable coins. So one of the problems with cryptocurrencies is that their volatility is not to everyone's taste. And for example, if you use Ether to bet in a prediction market, you actually have two bets running. One is on the event that you're betting on, and the other one is that the price of Ether doesn't move to your disfavor, right? And if you use a stable coin, in this case, Maker tries to peg it or to make it not volatile against the special drawing rights as defined by the IMF currency basket, then you at least don't have to worry about the volatility. So many see that stablecoins is something that we really need in this ecosystem to see more adoption. Golem is a project. They try to trade computing power peer-to-peer. Also, based with Ethereum, they're around very long. DigixDAO is another project. They tokenize gold, and they're your counterparty actually. So why would you trust them? Why would you do that on the blockchain? It's kind of there you come closer to a stable coin because gold is not as volatile as say Bitcoin or Ether. But they work with the best standards that the gold industry has when it comes to custodianship of gold coins or whatever. Nice guys based in Singapore, and I think they were the first who had a successful token launch, right?
Yes.
Good. First DAO. Okay. Then there's Singular DTV. That's a funny project because it's just, as I see it, it's just like a company whose shares got tokenized and were offered on the Ethereum blockchain. It's a project from Consensus. And they're in the, say, entertainment industry. They want to be the decentralized next Netflix. When we talk about entertainment, the blockchain offers artists to get directly compensated. You could use the blockchain to collect the fees or payments for the content and then directly distribute that to the producers of the content. Uport is an important project because it's solving one of the problems with identity on the blockchain, especially the question you often hear is, what happens if I lose my keys? Then it's like losing your passwords and you cannot recover it. Then you have no access anymore to your identity, whatever it is, and that on that identity could be your reputation points, but it could also be your money if you have that on a blockchain. So they're trying to solve that problem. There's 3 projects around peer-to-peer storage: StoreJ, Swarm, and IPFS. when it comes to peer-to-peer storage, you want to be very sure that your content is around when you log in the next time, that someone stores that, and therefore these peers need to be incentivized. Therefore, it's nice if you have some way to pay them. Again, blockchain is helpful here. Notary, that's actually at the core of blockchains. That's what they're really good at. They can timestamp data. And actually that's what happens, that's what's at the core of Bitcoin. The timestamps who has how many tokens on a blockchain. And FactCom is a system to make that, to scale it a bit so that you can have really many timestamps per second. And they look especially into property ownership. There's a lot of countries in the world which have no good registries for property, and FactCom is one of the companies trying to solve that. FactCom actually was initially based on Bitcoin, but now they also added Ethereum as their underlying platform. First Blood is in the esports business. Not sure why that's a good blockchain use case. Most likely because it's kind of betting, and whenever you have betting, then a lot of regulatory issues, same with prediction markets, might prevent your potential customers to access your system. On the blockchain, things are a bit more relaxed at the moment. There's two projects, no, actually three at least, about digital rights management, Ujo and Jack and Media Chain. Not only digital rights management, also about how the producers of the content get rewarded. Social networks, that's actually an interesting one. We talked about the FAT protocols. Currently, Facebook, Uber, Airbnb, eBay, they all are in the lucky situation that they have a monopoly on the social network that they actually provide only access to, but which emerges when users interact. They capture all the value. If you instead have these protocols in an open way, open protocols, and say structure all the data, the relationships the users have to each other on a blockchain in an open manner, then instead that value is captured on a blockchain, or rather there might not be any value at all, or at least it might be evenly accessible by anyone who wants to provide an interface to that data. So we have more competition on these nowadays closed platforms. And Akash.world is one of these examples. Governance is a big issue on blockchain. So if you have, for all of these projects, the question is always, say, if there's a million of users using these smart contracts, how can they be upgraded? How can the protocol be upgraded? Who makes these decisions? And therefore we need governance tools. A lot of them are structured around, I assume, liquid democracy style techniques. And these projects mentioned here, they're all a bit different, but a different focus, but I would cluster them in the category of governance tools. Decentralized exchanges, I briefly mentioned them earlier. There's two. One is called Ether Delta. One is called, actually not Maker, but Oasis DEX, but it's related to the Maker project. And one is done by Brainbot. It's called Radix. And there's plenty of more dApps. If you want to see a full overview, there's dapps.ethercasts.com, and they currently list more than 411 dApps. I'd assume mostly of them are not actively developed, but nonetheless, it's quite impressive what was started and is happening in the Ethereum ecosystem. Okay, these have been dApps which are on the mainly mostly public Ethereum blockchain. But there's also some industry players looking into the Ethereum stack. Could be the public blockchain, could be just the Ethereum technology. Recently, the Ethereum Alliance was announced. Alex is going to tell us more about this. There's a bank called Santander. They actually plan to issue Santander IOUs, that would be, say, euros, where you have Santander as the counterparty, which is not too bad, on the Ethereum blockchain. So that would be stablecoins issued by a bank. And they're also, I think, looking into correspondent banking use cases that they want to use the Ethereum platform for. Recently there was a consortium for IoT announced. Why blockchain for IoT? Some people say if you have no open protocols for IoT, and everything is run by SAP, for example, in their data centers. That would be, assume a smart city completely run by SAP. That would be a big honeypot for hackers, and it could be a security nightmare. You might not want to, probably most likely you don't want that. And a blockchain are seen, especially by IBM, as a good fit to solve that problem. Energy is a subsidiary from RWE, I think. And they have another sub-project called Share and Charge. So they have charging stations for electric vehicles. And there you actually pay with tokens on which are the payments go or are facilitated on the Ethereum blockchain. And they work with a bank which also tokenized euros and put them on the Ethereum blockchain. So you're using euros represented as tokens on the Ethereum blockchain to charge your car. Grid Singularity, there's a typo, sorry for that. And the Energy Web Foundation, they are building a consortium to use blockchains and open protocols on, especially here, the Ethereum blockchain technology, to build a platform that can be used in the energy space. One of the main applications in the energy space is probably peer-to-peer trading. So there's big shifts in the energy industry as we have more renewables, and these renewables are particularly owned by homeowners, by private persons who probably can produce energy, obviously also consume energy, but also store energy, because we have storage capacity soon in many households. Also your car, if it's an electric car, can store some energy. So you can trade energy with your neighbors, with people in your town, and you don't have to involve the big utilities anymore. And if you want to do peer-to-peer trading, you need an infrastructure, and again, it should be open, and their blockchain is a good fit. And that's what this Energy Web Foundation, which has actually very big utilities as participants, is about. I think you will learn more about this project in the coming weeks. Microsoft is a big supporter of Ethereum. They, I think, donate to Ethereum. They're part of the Enterprise Ethereum Alliance, and they make it easy to start Ethereum clients on their Azure cloud. United Nations, they just announced that the World Food Program is looking into building more accountable ways to distribute aid in the world. But actually there's 6 more departments in the United Nations currently looking into blockchain-based systems. Dubai announced they want to be a completely blockchain-based smart city by 2020. We'll see. Consensus is helping here. Yesterday, Spotify bought MediaChain. MediaChain is built on Ethereum. Today, I saw this. Google is also prototyping something on the Ethereum blockchain, but well, everyone is doing prototypes, so take this with a grain of salt. Okay, what about the future? How will the next 3 years evolve for Ethereum? Technology-wise, there's a roadmap, so I can tell you we are looking into proof of stake so that we don't need energy consuming mining anymore, but instead people vote with and have some stake and vote on state updates and thereby secure the blockchain. An important thing is scalability. There's 2 approaches, sharding and Raiden, which we're building, and both are needed. And I think to have private transactions, private data on blockchain is also a major advancement that we will see. So for technology, it's easy to predict what will happen. For the adoption side, for me, it's hard to say. So it currently looks quite good. There's a lot of momentum. Things are moving on faster and faster. But it's hard to predict where we will be in 2 years. I think that's it for my slides. Thank you.
Next, Alex? Ja. Bist du schnell weggegangen? Ja?
can get one drink from outside. That's allowed. But we will go on right in 3 minutes. Then I will switch to this. Okay. Das Kabel ist jetzt hier. Das ist, glaube ich, auch nicht zu viel. Kannst du dich jetzt vorstellen? Ja, ich habe es gerade versucht. Oder Gerd, kannst du gerade mal eben mit? Das wird ein bisschen schwierig, ne? Achso, und da hast du, glaube ich, schon das. Achso, nee, da ist ja nichts. Dann, sorry, dann geht's natürlich. Ja, super. Vielen Dank. Das ist die Blockchain, ja.
Nein.
Das ist die Blockchain.
Hammer. Wo kommen
Schnell
Sie
hinsetzen.
Wo kommen Sie her?
Brainbot.
Hä?
Brainbot, einfach einen Platz nehmen.
Ich muss mit genial Ethereum. Oh mein Gott.
Ja, einfach hier ist, glaube ich, dazwischen. Okay, yeah, I will talk in English, of course. Yes, as Heiko told, I will tell you a little bit about the Enterprise Ethereum Alliance. This is probably, as you have heard, if you are interested in Ethereum, you have heard this announcement. It had a lot of press, it had a good press, because also there are a lot of really huge companies involved. You have seen the slide already probably. I don't have to read them out, but there are really a lot of banks, but also other companies, IT companies, British Petroleum, something like this, where you can think of other use cases besides financial industry cases. So, the question is why do they form? What do they want? In fact, you can read it up. They are really open about their politics and about their decisions and discussions. They have a wiki, which you can just, it's permissionless. You can just go on it and see the mailing list and even apply for posting in the mailing lists. It's just a little difficult to find, so we will put the links on, I think in Meetup or something. I think it's because it's the early stages, so they don't advertise it in huge ways, but yeah, it's there. And you can see presentations, you can see the vision about it, so what do they want, why are they creating this group, and why is it necessary. I don't just repeat what's written on there, I will do it a little bit different. I give you a short agenda of what are the aspects, what is really important, and why is there an enterprise group necessary. And then I will go from a use case, a really simple one, to hopefully make sure why it's important to have such an alliance who addresses these problems. The aspects are the problems which you currently have with blockchain solutions in general, and also with the Ethereum solutions, is one thing, privacy and confidentiality, which is not the same as you can look it up. I can just explain it very shortly, but it's one refers to the person and is more important for the end users of something. So we are in this more or less public chain area here. The confidentiality is much more important for real transactions in a business space. So if we are doing a transaction and it's not so important that you are involved and I'm involved, but it's more important what data is transferred and what amount and what value. This has to be confidential. This, not everybody should know about this because it can be a competitive disadvantage then. So confidentiality is really important in a blockchain. In its usual implementation, you don't have this. You can see everything. That's the point in a blockchain. But yeah, this is an aspect which has to be addressed. Scalability, probably the biggest one, where you can see like, yeah, we have this consensus models of proof of work, which consumes a lot of energy, which is definitely not good for small chains where everybody knows each other. I will show later on why. But also scalability in terms of business functionality, where you say like, okay, I implemented something in a chain, let's say private chain, and I have another solution, identity solution, and I would like to mix them, have the synergies which Heiko told. This is something which is really important to see. How can this be solved? How can this be scalable in a private environment, in a public environment? Yeah, security is obviously a really interesting point, and it's not just about is the blockchain secure or something like this. This is like, yeah, it is, and so that's it. But it's more about like what is about the edges of it. What is about user errors, or what is about problems which come from malicious attacks inside a chain where people know something and can use this knowledge. And close together with this is permissions. So permissions in a blockchain are really difficult to implement. And you will see with the usual Ethereum blockchain, you can have permissions on different levels, but definitely not on these levels you need for an enterprise environment, where you have roles and rights and different layers of permissions which you can have. So these are the crucial points where enterprises said like, okay, with the public Ethereum blockchain, we will have difficulties with respect to these aspects. So we just start with a really simple case, and if I understood it right, there are some developers here, so for you it will be like, whoa, that's incredibly boring. But in fact, it's a real use case. It's a really simple use case. It's called stamping, and stamping more or less says, if you are in a banking environment, then you will know. Let's say we have 6 different banks over there, and these banks have their own data storage and everything, and we have these all-seeing eye, which is the regulatory instances, whatever, and they are looking on. They also have to see what's going on in these banks, and inside these banks, everything is just working fine. They are, let's say, they are offering a product, a financial product, and then they do publications for this, and they have to offer certain metadata, I would say, for these products, and they have to, or they want to exchange with other banks some information. And this is the problem, because then they get through from these nice processes which they have to generate all this stuff. They go down to like email and internet and Excel and whatever they have as a common infrastructure if they are competing banks. And usually you have something like this. So as a really small example, it would be like, I want to sell a product from your bank, and you are saying like, okay, I have all these publications, and I have to make sure that you really signed them. I have to make sure that it was really you who did it and everything like this. So if we are doing this bank to bank to bank to bank, then we have a lot of reconciliation processes going on, and this is really a costly process going on. So this really costs a lot of money, in fact, people who are doing this. And it's more or less because they cannot have a common infrastructure because they are competing banks. They don't have it. This can also be a case of a huge company with different subsidiaries. And the subsidiaries probably have some infrastructure, but still they have internal accounting, and they are not competing, but they are separated from each other. So they have the same problem. They have to exchange, I would say, some information, and this information is just exchanged in ways where you have to have reconciliation, where you have to make sure that all data pots are in sync, and this is really costly process. So what is stamping about? Stamping means that you have some digital document, whatever I would say it now, some document, and you are doing hashing. So this is nothing really special and nothing new for some maybe, but it's nothing, not a new invention. You can go from the document to the hash, but you cannot go back. But you can always be sure, at least with current algorithms, that this document will always hash to this, and no other document will have this hash in it. So if you think about this, okay, this is taken for granted, then we are not talking about documents. We are talking about stamps, fingerprints, whatever you will call this hash. And when you use a blockchain, then you have something like attributable data, it's called. So you can say who did what when. This is a really important point. So you can say, like, I created a document, I published it, you read it, I did a new version in it, and everything is written on this common infrastructure layer, which we would call a blockchain. Right now, it's done with mail, Excel, reconciliation, databases, whatever. All things are going on. So this is one point, attributable data, which is really important. The other is something which we call deterministic computation, which means with attributable data, we just have the data itself. With deterministic computation, we really have logic, so business logic, I would say, which runs. And this is something which only blockchains with smart contracts, in which way they support it, can use. So I think this would be quite complicated using the Bitcoin blockchain. At least it would be more complicated than with a programmable blockchain. So here you can say, like, okay, I have a state of a document, or of this stamp, of this document hash, and I can really do state transitions, the computation, and I can react on something which the other bank does. So what we get here is this deterministic computation on this blockchain in a agreed upon manner. So we have to agree, all who are participating, that these state changes should work in exactly this way. So there probably you can see the first point why you have to have this in an environment where people get together and talk to each other and have to get together to form a solution, because this is a lot about hard work for people to agree upon one state change. But if they do, they have a lot of advantages from if you compare it with the current situation. So it would be something like this, where you can see now this is in the blockchain, the document, or here it should be better the fingerprint, is one single point of truth for everybody who's participating, with a state which is the same for everyone. The document is the same for everyone. Everyone knows who did what with this document and at which state it is. The regulator knows, so it's much easier. And if you see the red almost circle, this is the same as here. And the important thing is here, it's around these entities, these small banks with their own data stuff. This is like where their processes, this is their process context. So their processes are really quite lean, usually, with banks. So they're quite sophisticated. They know when I'm going to publish a document, then I will do this and that and get data from here, and everything is fine. If it leaves, if you leave the process context of one single entity, of one single of these banks, then it goes down to this mess with internet, email, and stuff. And what you do here is like extend this process context to all participants. And this is also hard work. It just doesn't come from itself. But if you do it, you obviously save a lot of money. So this is something like a really small use case. We want to say, okay, we use stamping, we use hashing for this, we use state transitions and smart contracts. We don't have to, but it makes sense in this way. And so, yeah, we really could save a lot of costs. And if you want to set up something like this, I think everybody would agree to say like, okay, there are 6 banks. Why should we do it public at first? It doesn't make too much sense. If we start with the usual Ethereum client and we are going on and then this works, we have this genesis and everything, which makes sure only these 6 people are participating. And then you do proof of work. You are mining something which doesn't make any sense at all because you are mining some currency which doesn't have value. And so it's you need proof of work to really be sure that there is someone you don't know who does the work. Here, you know all entities. They are known. They are other banks. So it makes much more sense to really have an incentive in form of not some currency or something, but your banking license. If you have a banking license and you try to forge in this context, then you may lose it. So these are known entities, and you don't do something like proof of work with it. So we have like 2 crucial points: scalability or consensus model, and privacy, confidentiality. And another point is, how do you onboard new members? If you have a successful model and you have a really slim process, then how do you onboard new banks? Because they want to participate. They see like, oh, we are still doing here all this Dexel stuff and everything. Like, we want to be in part of this. How does it work? And these are all interesting points which go to private chain first, I think. All would say like, okay, it's easier to do. Onboarding might be a little more complicated, but yeah, all other points are speak for a private chain. And also the alliance says like, yeah, people will start doing this. They will have their, if you take this intranet analogy, they will have their private chains, their intranets, where they will do nice stuff. And at some point, probably they will see, okay, we cannot use these synergies and everything because we don't have the possibility, because we have a private chain here, private chain there, and private chain there, and we cannot interoperate with this. And then we have to invent all this stuff new, and we have to build bridges and everything like this. So what we think will be one case is this KYC, Know Your Customer and Identity solutions, who really involve the customer, and then you will have to open it to the public somehow. And you don't know how you will do it if you have a private chain. So the one strong belief of the Ethereum Alliance is, yeah, we have to support enterprises with pluggable scalability, pluggable consensus models. So you can proof of work, switch to proof of stake, switch to proof of authority, everything like this. Probably also have configurable privacy and confidentiality. But they do all this to make sure that you stay compatible to the public Ethereum as long as possible, to not have you with an intranet which just is not connectable to any other intranets which are always there. So the idea is, if they will have a reference client, which they plan to do, then it will have all this pluggable stuff, and it should be compatible to the public client. And they want to stay as close to the public client as possible, because they say like blockchain solutions is always about synergies, and this you can only achieve with public chains. But yeah, they also say like start with the private chains. It makes sense, and you can start with private chains only if you have consensus models which make sense in this private environment. You don't want to have 6 participants and one is buying 10 new nodes and then you can do an attack or something like this, because proof of work really doesn't make sense in this context. So here are some of these attributes for private permissioned and public unpermissioned chains. And I think it makes sense to say the short-term solutions will always be a better fit with the private permissioned chains, because it's easier to start with, because it's easier to say like, okay, if I do updates, what happens with updates? How do I do updates? How do I do versions? What is about the shared administration? Yeah, all these performance issues. If I can just really easy switch to another implementation and try it out. With a public chain, this will be the thing about synergies, where you say like, okay, how do I get new participants into this? How can I scale in terms of business functionality, in terms of use cases, so that I can say I have this identity solution here, I have this settlement solution here, I have this here. How can I combine these? And I think this intranet analogy really fits quite well. Just with one point that one has to keep in mind, that this have the best solution for my problem is a little short for blockchain solutions, because this is really about integrating stuff and having synergy effects. I also said the one aim, really, one goal is have a pluggable consensus model, have the possibility to just say, okay, we don't need proof of work, we just need proof of authority, where you know the actors, and you can just say, okay, you and you and you are allowed to participate, and the others just can't. Then you can also say, like, then of course we don't need consensus with proof of work, it doesn't make any sense, so we could do round robin or whatever, or tendermint, like there's some resolution processes inside, but still you can really have easy solutions and they don't cost energy. And then you could say, okay, now we go to this public chain, now we have to do proof of work, and it's just more or less like a switch, which I have to do. What is the best fit has to be really is use case dependent. So you have to know if proof of stake might be a fit, or proof of authority is just better. But it should be really easy exchangeable. I brought one solutions to show you how strong their opinion is to find generic solutions, which is the zero knowledge proofs. So definitely don't have to understand them. I couldn't explain either, but I have a really simple sample where you can see why they are important. What you have to keep in mind is, for a use case specific reason, you can have privacy and confidentiality implemented for this use case. So you have to think about it, and then you'll find a solution with some off-chain components or some whatever. It's almost possible quite easily. This solution is a more complex one, and this explanation is not technically correct, definitely, but it's for illustration purposes only. It's just to show that this exists already, and you all who are using the blockchain, whatever blockchain, really are trusting this mechanism. The mechanism is more or less, I have a claim. The claim here is I have a private key for some Ethereum address, and I can show it. And I don't show it if I give you the private key, because then it wouldn't make any sense. You know, then the whole system fails. The private key has to stay off-chain with me. But I can sign a message, I can give you the message and a signed message, and you can derive the public key, and you can derive your address, and say like, okay, it's true. If I trust mathematics or algorithms or whatever, and currently it works exactly this way, then I can be sure that this guy has this private key to this address, even if I don't know it. And this zero knowledge proofs don't make so much sense in this case, or they make much sense, but for our use case not. But if you think of something like we are doing a confidential transaction, and I give you something, then people will know, okay, he gives something to him, but it's hashed. You don't see what amount of value it is. It's also not really important. What's important is that we agree that I cannot sell more to you than I have, and that the balance of mine should be less than before, and something like this. And if you have a proof which says like, okay, after this transaction, it's sure that he still has some tokens, and you have more, and exactly the difference, then you don't have to know what the exact value is. So this is more a generic, quite complicated solution, but they are trying to push it because they say like, yeah, if it works, and there it works definitely. It's just like a thing about how good does it work, how easy can you use it. There is some baby Zoe zero knowledge on Ethereum, which showed that it works. But it's just to show, yeah, they are really honest about this stuff. We want to give generic solutions to be able to switch from private to public. Security and permissions is what I said. Like, yeah, you have like in a proof of authority, you have some identifiers for validator nodes, and only they are allowed to participate. So it's a completely different thing from unpermissioned blockchains, where you do your proof of work and everything like this. Here you say like, okay, you are allowed, the others are not. This is something where you can prevent someone from getting into the system, but it's nothing to do with permissions or something like this. Permissions you can do contract based. You can do something like this. If you know Ethereum, you will know this. Yeah, only the creator of this contract is allowed to do certain stuff. So this is the if sender is not owner, then throw. So this is the contract-based permissions, and if you know the enterprise environment, you know that okay, that's nothing. We have to have roles, users, user roles, rights, concepts, and everything like this. So it gets much more complicated if you have an enterprise grade or enterprise granularity permission system. So this is something you can implement for yourself all the time, or the Alliance finds templates, finds best practices, finds something like this in their working groups to give you advice how to implement it. This is what they care about. So all in all, really in just these points. Scalability is really the thing about the pluggable consensus. It's really important that this works, and there are also in these clients right now, I think it is even possible right now, but they still have to modularize it a little bit more. Sharding, parallelization, I didn't speak about. State channels you will hear a lot about today. It's also about scalability in effect. Privacy and confidentiality, ring signatures, and the zero knowledge proofs address all these facts. This is our research in the Alliance. Individual solutions templates for industries, for special industries, like certain industries like medical, or for banking, where you have probably a little bit different understanding of privacy and confidentiality has to be worked out. This is what they do in working groups. Then security and permissions, even on an application or user security level, which is quite interesting. If you think of, if you are working in a huge enterprise, you know that they have they say like, okay, we use these algorithms for security related issues and no more, because these are whatever, like went through thousands of documents, and then they are fixed. And so you cannot just use this Lampert whatever quantum proof algorithm of Ethereum. So you have to have the possibility to switch this also per user, per application. This is also something they are working on. And probably one of the most important facts, something like to have a governance for updating, versioning, shared administration. Because what is it when we are 6 companies, and how do we do our contracts? Who administers it? So each person for itself, of course, but still we have to stay interoperable. So we have to have some consensus about when do we upgrade, what do we upgrade, how does it work. So in these member interest groups, they are addressing exactly this stuff. I put one Brainbot slide in here because just for you to know that it's not only in San Francisco and New York and wherever these companies are, it's also in Mainz. That there is a company addressing all this stuff. Also, as I think it's true as a member in the technical steering group, as a member definitely of the EA. I think also as a member of the technical steering group, and for active development of the reference enterprise client for Python. They are doing all these projects, which you will see later on. Okay, we have some resources here. These will go on as links on on the meetup space then. That's it. I don't know if it makes sense to make a question and answers now, or do just a break and then you can come here, ask me, or go outside.
I would like to have a 5-minute question and answer to the speakers. Just a real quick 5 minutes. If anyone has some questions, and afterwards we will have a little break. Drinks and food is free. Sponsored by PwC, sorry. Yeah, common mistake, I guess. And after the break, we will hear Andreas from Deutsche Börse. Any questions to the speakers? Yes, please.
Yeah, so I have a question regarding the outlook for the transition from private Ethereum chains on the public chain. Yeah? Because once you switch to proof of stake, and we all know that the distribution of wealth in Ethereum terms, in Ether terms measured, is extremely unequal. Yeah? So you have a lot of market power of very few players in the market. So do you actually believe that banks will put their fate into the hands of a few people that are validating the transactions in the proof of stake framework? I think that's, rather unrealistic.
I would also give this question to Heiko, but I would say it depends on how you find solutions to this shared admin stuff and the update stuff and all this. Like if the other people can just destroy anything, then it doesn't make sense. But if you find a framework in which you can really find solutions for this shared admin, for the versioning, for something like this, and even have something like emergency measures or something, then it could be. But it's definitely it's a problem. Yeah, if you have to rely on something like this. This is one argument for private or consortia chains. Then, yeah, but I don't know.
Michael? So with proof of stake systems, then how you design them, you can actually exactly calculate how much value is currently secured when consensus protocol rounds run. After every block, more history is signed by more participants who have something at stake. So if they at some point decide to not vote for that history, but for a different one, they will lose their stake. So with every block that passes on, the security that you have gets higher. And you can actually measure that. You can exactly calculate how, in monetary terms, secure that history on the blockchain is. That's not answering the question.
Okay, you can do a follow-up question in the break, maybe. Any other general questions to the speakers? I guess it's break time.
Yeah.
We'll be back in, let's say 30 minutes. Or, sorry, 20 minutes. So 5 past half.
So, aber jetzt geht es auch noch spannender weiter. Du hast jetzt nur diesen Ethereum Enterprise.
Nee, ich habe so viele, weil ich bin Ökonom.
Ja.
Ich finde es immer interessant. Ich habe mir relativ viele Gedanken darüber gemacht, über so die ökonomischen Dinge. Aber ich verstehe natürlich die technische Seite nicht richtig.
Ja gut, aber das ist ja...
aber ich habe das Gefühl, auf der anderen Seite ist auch die ökonomische Seite nicht verstanden.
Ich muss nur anschließen.
Also das ist eine Sache, die ich mich frage, ja? Weil eigentlich die Grundidee, und das ist ja so ein bisschen, sagen wir, die Grundidee von Blockchain und Validierung war ja eigentlich so,
So maybe we can just have a short experiment. Like we all imagine we have a ledger, spreadsheet, and there's three entries. Alice, Bob, Charlie. Alice has one token, Bob has two tokens, Charlie has three tokens. All of you have that ledger in front of you. And now someone sends me a transaction says there is one token from Bob to Alice. After that, obviously, Bob only should have one token, instead Charlie, Alice should have two tokens. But how does it work? So the transaction is what we call a flat flow. I send it to Alice. He sends it to the guy next to him, and to the guy behind him, to the guy in front of him. They send it to their neighbors, it takes a few seconds until everyone got the message. Then everyone updates their not confirmed yet copy of the ledger, copies the ledger, does the transaction, and then tries to solve puzzles. And the first solve the puzzle sends his ledger and his list the puzzle to again. Come over with the all the way around the takes one of them. And that's the problem that we have. That's what it goes if we have shared ledgers. Everyone needs to have the same data, then we have latency. And if you now imagine last time we had really slow internet. And it takes some time until we get the right. And the Raiden network tries to solve this technology, this problem by not sharing data with everyone, but opening stage of payment channels. It is, and now you kind of understood what the problem might be.
You are watching an IoT demo based on the Raiden network, which extends Ethereum to support fast, scalable microtransactions. We constructed a small IoT demo where a producer sells energy to a consumer. The provided and consumed electricity amounts are metered, and the consumer pays for every 2,000 watt-seconds consumed. If the provider is not receiving
an electricity meter reports consumed energy directly to the producer, who then has the ability to switch off the energy supply by controlling a relay. The consumer's node also meters the energy consumption and sends out a Raiden transaction based on the meter's impulse. Attached to the consumer socket is a 1 kilowatt floodlight, which turns on as soon as the consumer sends out their first transaction. Every 2,000 watt-seconds, the meter's LED light blinks red and sends out an impulse to the Raspberry Pi, which automatically initiates a Raiden token transfer to account for the consumed energy. On the right-hand side, we see the remaining funds of the consumer that decrease according to the consumed energy and immediately get added to the producer's earnings on the left-hand side. The consumer will continue to receive electricity as long as the Raiden network is able to transact funds from his account to the provider. Looking at the consumer's log output and the electricity meter on the right-hand side, the meter's impulses are shown by a blinking red light. Notice that the consumer receives the producer's transaction acknowledgement nearly instantaneously. But since the consumer will run out of funds soon, it won't be able to continue sending payments. Consequently, the producer switches off the relay, and therefore, the lights turn off. In this setup, every 2,000 watt-seconds were accounted and paid for. Bound by the floodlight performance, this resulted in one Raiden transaction approximately every 3 seconds. Widespread adoption of microtransactions for IoT will require transactions that can be settled faster than what traditional blockchains are capable of. Raiden inherits the permissionless programmability and security properties of the Ethereum blockchain, while being able to scale to millions of participants, each doing secure financial transactions every few milliseconds.
Over there, he built the IoT demo. Right. So if you have some questions about this, then you can go to Max Ulo. And if you like the voice, then Christopher is the voice over, and he's next with the presentation on Trustlines. Oh, hi.
walkthrough of the technical implementation, and finally a short recap. So by now, what you've probably heard
about Ethereum and blockchain in general, but especially Ethereum, is this ability of synergy. Really, we have people from every kind of industry defining their own problems. Yes, sometimes they're good, sometimes they're not adequate blockchain problems, but either way, different kind of people, different kind of cultures and groups coming together and seeing there is something we can use Ethereum for and solving a problem with. And this is of course great because when you're on the same network or you're using the same token, there is an immense amount of interoperability and synergy within that. So what that should do is obviously it should drive a lot of adoption, right? Because we have people from the UN, people from the bank sector, people from the music industry, they're all coming together around the same thing. And of course it is, except there is a small problem. And this is something that most of you who are economists and relatively technical guys have seen already, is that we would think that blockchain technology is kind of the killer application for payments, right? That's what everyone heard. That's probably back in 2011 or something when first heard about Bitcoin or whenever it was, that you could pay someone without any intermediary and you would just have sent money and that was it. Of course, that's not really how it works. So we can do a quick walkthrough, very easy. If you want to buy your first Bitcoin or your first Ether, what is it you do? First, you download an app like Coinbase. Then you confirm your account. Then you send money with your bank account. And no, you don't get to use your credit card. You use good old regular IBAN Swift transfer. You wait like 2 to 3 days. Then you have some money on an exchange. And then, boom, you're ready to adopt the whole innovative, explosive growth of amazing Ethereum stuff. Not really the greatest use case, right? It's not really the greatest way that we want payments to work like. That's not how payments are supposed to be, and it's certainly not the way the payments of the future are going to look like. So what I'm trying to get at here is that in order for cryptocurrency to be used for payments, we have to outcompete existing centralized payment services instead of relying on them. And one of the ways we can do this is by using the original Ripple idea. And I'm saying the original Ripple idea because it's not what Ripple is doing nowadays. This is the original Ripple idea, originally written by Ryan Fugger in 2004. And it kind of goes something like this. So you have a global payment network network of payments based upon individual trust relationships. And if we forget payments for a minute and just talk about trust, this is similar to how you would use trust. Actually, it's completely like how you do trust in the real world. So I know a guy called Bob. I trust Bob. If Bob came over to me and said, hey, Christopher, do you know Sally? And I would say no. Well, Sally's my cousin. Can she borrow your bike? I would say yes, of course, because I trust Bob. So I know if something happens to my bike, I can go to Bob. Very simple. If we reintroduce payments into this, introduce credit line, we have something called credit lines. And who do you have credit lines with? Exactly the same people that you trust in the real world. So your mom, your son, your dad, someone that you trust personally, you could give them a credit line of 10 euros. And this is something that you do already. For example, if you're hanging out with your mom and she forgets her credit card, you would lend her money to buy groceries, right? What happens there is actually you're giving her a credit line. She's able to spend some money in the real world, and you will get paid back at a later point in time. You don't need to set up an account or a contract to do that. This just kind of happens. What's cool then is if we could use this and set up bilateral credit lines, we could establish something called Trustlines. What could we use Trustlines for? Well, Trustlines are bilateral credit lines which are set up in this payment network. And so if Alice and Bob have a trust line, they're saying, well, Alice says to Bob, I'll give you a trust line of 10 euros. You can spend 10 of my euros anytime you want. And Bob says the same. So if they're going out to buy beers, what happens is that Alice is now getting beers, or no, Bob is now getting beers. And so in order to pay for those beers on credit, what Alice does is she spends 5 of her $10 trust line with Bob, making her balance 5 and making his 15. So he has 10 of the credit line he originally has, and then 5 that she owes him more. So in that point of time, we actually have money which is created. The imbalance between these two is where money is made. And that's kind of fine and dandy, but it's not really that interesting, because if it's just on credit that people trust with each other, then how are we going to use that? What would be much more interesting was if Alice could use this to actually buy the beer and not have to just use it on the separate. So if Alice wants to pay Charlie and they don't know or trust each other, what we can use this payment network for of individual trust relationships is to look for a path where we can make a payment. And that path must, of course, have sufficient capacity. So if we have a path that runs through Bob, what we do then is we say, well, if Alice sends $5 to Bob, that reduces her credit line, or reduces the balance in her credit line, and then sends another 5 to Charlie. Charlie has now received $5. So what happens for Bob here in this case? Well, for Bob, there's not really any difference because his net balance remains unchanged. Bob has $15 of credit he can spend one place, and he has 5 in the other one. And so he has 20 total, right? For Charlie, this is good because, or for Alice, this is good because she's now paid someone and gotten a beer, which is what she wanted. And for Charlie, this is good because he doesn't actually get money from Alice, he gets money from Bob, who he trusts. So he doesn't get the credit that he doesn't trust, he gets the credit that he trusts. So that's nice, not really super efficient because you wake up in the morning now and you're like, okay, I need a bus ticket. Who do I have to settle with in order to get money in this network? But that's kind of the cool feature of the setup is that we mostly don't have to settle. So if we add Dave into this equation and then he now wants to pay Bob. When there are many trust lines or when there's a network of many trust lines, debt flows in many directions. And so this creates a circular flow of money, meaning debt cancels out over time. Payments go in multiple directions, and so real-world settlements are mostly not necessary. As you can see here, Dave makes a payment to Bob, which cancels out his debt with Charlie. However, relationships, they are not static. Sometimes they change. Sometimes people have fights, and they don't like each other anymore. So Alice and Bob, they get into a big fight, and they don't like each other. It would be kind of easy if Alice was just owed Bob. She would just pay him and then say, I never want to see you again. Pay the debt, and then close the trust line. It's a little bit different if Bob owes her money, because she's not going to say, I never want to see you again, by the way, please give me 10 euros. But there's a function in the system called payment to self, which allows you to control the individual trust lines you have so that you can, so that in this instance, Bob becomes indebted to Ed, who becomes indebted to Alice. And for Ed again, his net balance remains unchanged. For Bob, well, he was already in debt, so now he's just in debt with another person who he trusts and has a trust line with. And for Alice and Bob, they can now close their trust line because it is 0, so they no longer need to have that open. Why is that a good fit for blockchain? Why is that a good blockchain use case? Well, it involves a lot of trust. Or like all credit and debt, it involves that if you don't have somewhere to settle this, a global ledger where everyone can see the same thing, it's very difficult to manage whether or not things actually happen. So it's very good when you have a blockchain where you can see the debt relations of everyone. So the Trustlines network is 2 things. It is a decentralized protocol for customizable and interoperable complementary currencies, and it's a mobile payment application with a focus on ease of adoption. So let's start with the last one first. On the Trustlines network, remember how I told you about the onboarding experience of getting a regular cryptocurrency, or right now, but on the Trustlines network it's a little bit different. So there's no registration. You don't need to confirm your identity with the account you're using. You don't need a bank account. You don't need a credit card. You don't need to deposit money. And most importantly, you don't need any ETH. Nonetheless, you can start doing payments within a minute. That's pretty unique. The way that works is you download an app from an app store, whichever one you want. You join by creating a trust line with a friend, and then you start sending and receiving payments. And that's it. So some of the things you can do with the Trustline network is, for example, you can get access to cryptocurrency. So if Alice wants to buy ETH, she thinks there's a lot of cool applications, she wants to use that now, but she doesn't have any. Well, what is she going to do? She wants it, but she knows that Dave has some, but they don't know or trust each other. Well, we can host the ETH, or what Dave does is he hosts the ETH he still offers the ETH on the decentralized exchange, and he says, I will sell ETH for 50 euros a piece if someone is willing to buy it for that price. And Alice says, that's a great price, I want to buy that ETH. So she sends $150 of Trustline money to Dave. And if there is a path of sufficient capacity, meaning if we can credit Dave in the network with $150, well, we do an atomic transaction where Alice gets the ETH, and Dave now has $150 of Trustline money he can spend. So this solves the dependency on centralized exchanges and removes the requirement of having a bank account, and also removes the requirement of meeting in the real world. So would like to compare this to My Local Bitcoins, if you're familiar with that, except from the comfort of your own couch. It does require that there's a sufficient amount of users who are willing to sell ETH in the network. Another bonus for us is that it allows us to give a very good onboarding experience because, of course, we're not magicians. You do have to pay gas in order to send transactions to the Ethereum blockchain. And if a new user were to join and they had no ETH, obviously they would have to pay for that gas. But what we can do is the onboarding person sends a small amount of ETH when they onboard someone, and that pays for quite a substantial amount of transactions. So that creates a demand for ETH in the system, and it also creates a natural interest to get ETH. One of the cool applications to that is, at some point in time, you will most likely need to buy more. When you need to buy more, you will have an easy way of purchasing that ETH. Furthermore, ETH can be used to interact with any application on this ecosystem. So basically, you download the app, you connect with a friend, and you get access to the whole ecosystem. Another application we have is called people-powered money. And people-powered money refers to, there are three kinds of money in this world. There's bank money, there's government money, and there's complementary currencies or people-powered money. And the basic idea is that we're seeing a digitalization of different kinds of currencies. There's many different kinds of money being made right now. The question is, how can we use that on an open decentralized protocol to enable people to build their own kinds of money? That sounds completely insane, but it's not actually that far-fetched. When you think about, for example, frequent flyer miles, an amazing application of complementary currencies, very, very powerful, very, very good, creates a lot of revenue for some companies. In some cases, for example, American Airlines has 50% more revenue from frequent flyer miles than they do from selling seats. So why is that? Well, they have a lot of fixed costs on planes. No matter what, a plane costs a lot of money to take off. And obviously, when you have a lot of fixed costs and you can't always sell seats for regular money, having a complementary currency to encourage those sales is a great use case. So wouldn't it be awesome if there was an open protocol where it wasn't limited to someone who just has a lot of trust, a lot of money, and a lot of interoperability with banks to create that, but regular guys could do the same thing because they were using a transparent protocol where anyone could expect the code and say, this looks interesting, this looks trustworthy, I trust this kind of money, I will integrate that into my bus driving company. Some other applications are expenses, loan savings, and crowdfunding. I'm not going to say too much about those, except it's very useful to have digital payments when you don't have a bank account and get access to digital payments if you're amongst the 2 billion people who don't have bank accounts. How was the time? Should I? Yeah. Okay. Currency networks are in smart contracts. They're hosted on their own separate smart contracts. The interoperability, cross-currency payments, we use ETH as a bridging token between the different networks. So the reason why we use a decentralized protocol to do this, and the reason why it's not, why it's different, for example, than just having a bunch of separate applications that run this on their own, is of course that we can use ETH as a way for different currency networks to trade with each other, and it works very similar to how the ETH to P2P, ETH to fiat exchange does. The architecture. On-chain, the mobile app is where we sign transactions. We use relay servers to relay transactions. We have a bunch of fees. You can come ask about those later, but basically we have two kinds of fees. We have Trustline money fees and we have gas fees. The Trustline money fees we only really have to incentivize debt cancellation and have a balanced network, and the fees, mandatory fees, well, we have those so we can send transactions to the Ethereum blockchain. So this is an old and powerful idea. If implemented on Ethereum, it has a completely unique onboarding experience that can drive mass adoption to blockchains and aims to deliver scalable and decentralized permissionless global payments based on people-powered money. It's in development at Brainbot Technologies. We have a working prototype, which we hopefully will release next week. If you're interested in this, check out the website and read our white paper. Ask any questions here or on Slack. And if you think this sounds cool and you want to develop on it, join our development team. Thank you.
I have one question. Why did you mention our target group, the unbanked?
Why didn't I mention this? Because I thought it was more interesting to talk about people-powered money. We explain it a lot, and well, if I was here for an hour, I would love to talk about the unbanked as well and people-powered money, but since we're using this term, I felt like we should go more in depth with that. But the unbanked is obviously a huge application on this, because if you don't currently have digital payments and you don't currently have a bank account, but you are getting smartphones and the smartphone penetration is increasing in areas where we see large populations of unbanked people, of course getting access to a mobile application where you can do digital payments and savings, and where you can actually, I mean, even if you, wow. Yeah. So that's a killer application. Yes. Question there?
Yes. As far as I know, it's so. Actually, I have two questions. First, so the way I see it, you basically have these weights on these paths, and you assume that the whole graph will basically like the weights they will always go to zero. In the end, they will go back to the 0 point.
Mm-hmm.
So how can you assume that? So why is that? And the other question is, as far as I know, it's very, very difficult to find paths in graphs. So how do you solve that problem? The problem of finding these really complex.
It's my answer.
It's two technical questions, kind of. So for the first one, we use fees. So in order to, we've been talking about the rebalancing, right? How do we cancel out debt?
Yeah.
How do we make sure that the balances don't go into one direction, but rather that we use paths that help to rebalance? And we do that by having an according fee structure. We have a fee structure where it's more expensive to add more imbalance, and it's cheaper to reduce imbalance. So then the path finding algorithm tries to find a path which is the cheapest. Right? For the path finding, you're right, we cannot do that on a blockchain, we cannot do that in a mobile phone. Therefore we have auxiliary helper services, like a federation of services which know the current state of all the trust lines and their balances and their capacity. And then you can just query them and ask them, hey, please give me a path from Alice to, say, Charlie. That's how it works.
There's a question?
Yes. In traditional banking IT, when you have a debt, it's just a number with a minus sign in front of it. In blockchains, money or assets are represented as cryptographical primitives. How do you represent negative debt? Well, debt in all as cryptographic primitive. Is there a way already to do so?
That's not a microphone. Yes. So the important thing here, the Trustlines, that's not tokens. It's not tokenized like you could count positively, like there's 1 token, 3 tokens, and you can pass them around. Here you really have balances, like in banking, and these balances can be negative. And the EVM, the Ethereum Virtual Machine, supports that you can represent negative values.
That's I know, but you cannot verify across nodes that a balance or an asset is negative as a debt. You can't do this, or you cannot. Well, that's a question. That's not a claim. Can you pass around this? Sorry. Can you make this in a hybrid blockchain or in consortium blockchain so others can look into this asset and see that it's a debt?
Yes.
It's a centralized system because you say you have a record, like traditionally, which says someone owns.
Yes.
Or is it cannot be passed around?
The debt can, in this special system, not be passed around because the balance always only exists between 2 participants, right? They have between them and balance or imbalance. It cannot be passed around. It cannot. If you're indebted to me, I cannot pass that to someone else who then uses the money I would or the credit I have with you to pay for something. That's not how it works.
Settlement to exchange debt. There's no way people can exchange debt independently. Peer-to-peer, there's no way to trade debt or something like that.
To trade debt, no. Yes.
Yes?
Do you know how much time will it take to do a transaction from one to the other, and how big this network can be?
How much time it will take to do one transaction?
Yeah. Do you already know that? How
No, not really. Do you know this?
But it takes us personally in the first incarnation of the system we build on the Ethereum blockchain, on the public chain as it is, there will be as fast as we have transactions in Ethereum, that's around 15 seconds. But you should wait some more blocks for confirmations. So say 15 seconds for, you get initial confirmation that the transaction is valid, and then you're already 90% sure that it will go through, and then wait 10 seconds or whatever, and the longer you wait, the more sure if you can beat that transaction. It will never be reversed on the blockchain.
The more people there is in the network, then the more...
No, that's actually not a problem. That's not a problem. Then that would be a problem.
Yes?
What happens if the trust line is broken by an unforeseeable event like death? If there is debt in this trust line, including several nodes.
If a trust line is broken, the person the next person whom you have that trust line with, would be the person who would be liable for that amount. If you mean what happens in terms of how would you settle if one person dies or disappears? Yes?
You are relating that one person is one phone, but what happens when one person has two phones or two of these lines? It's just two line of debt.
So
You are trusting the same person.
yeah, that's a good question. I mean, if you have, since you're always going to be confirmed by your identity. So if you for some reason would want to have two different accounts with two different trust lines, the people in who you have trust lines with would know that that is the same person, because it's people that you know in the real world who confirm them. Does that answer your question?
Yeah, but for example, if you are the other guy, that it's the third line of this ed guy or that date guy that you were saying, that you don't know the beginning of the line, which is Alice, then if this ed guy has like two phones.
But that's not relevant for the ed guy, because if Ed is here and there's like 6 nodes between Ed and the person with 2 accounts and something happens here, Ed has nothing to do with that. Ed has something to do with Charlie, who is next to him, because that's the person he has a trust line with. So basically, if you would want to play that out, what would happen is the person who is closest to the person with 2 accounts would say, hey, something is missing here. I have a trust line with you. What's going on? Why are you defaulting on one or whatever it would be?
So if I understand, I mean, you're managing pretty much credit scores somewhat. So I have a trust line. I have 100 Facebook friends, and everybody I say, okay, I'm like, I trust you $100, which could put me in debt of $10,000. My question is actually, what I understand, if you want to find the cheapest path between 2 parties, that's actually an NP-complete problem to solve. That's one thing. And then once you've found it, do you need to lock it? Because otherwise, if you have parallel transactions running on the system, you should prevent a graph from being broken from another transaction, because otherwise you might have a deadlock. How do you manage that?
Yes. So the path finding server proposes a path, and it must not be the optimal path.
Okay.
Any path which works and is cheap, and we can say there's probably no cheaper path, most likely no cheaper path. That's a good enough solution at that point. And then actually send the transaction into the blockchain. You say that's the path A, B, C, D, E, and that gets applied to the state atomically, right? So the account updates are all done within one transaction. That's one atomic transaction. So during that transaction, you will have no conflicts. What could happen though is obviously that the pathfinding server proposes a path, and you send the transaction in, and there's a conflicting transaction that came before that, and so that the path was not viable anymore. That can happen. But then, well, the transaction does not go through as accepted, but throws an exception, and then you just try again. So that's, say, optimistic concurrency that we have here. Most likely there's never a conflict.
Yes.
I'm curious, how robust is the network to attack vectors? Has there been done any security audits or?
So one obvious attack vector is not technology-wise or implementation-wise, but when people would come up with cyber attacks, you would just create 1 million accounts and then get a lot of credit in the system. That's what you initially believe. But you can only spend money through connections with real life people that you actually know, and they wouldn't go give you more high credit lines than the money that you trust you with. So if you create like 500 fake friends and give each other or yourself to the fake friends a lot of credit, it doesn't help you to spend it in the system. Because your friends are not connected to no one except for you. You're the only real person who's connected to nothing. And your friends, your real friends, wouldn't give you that high credit.
Yeah.
Another question, do you have some adaptive algorithms that say my close friends start to get more and more in debt? I pre-trusted everybody but with like $100 and then I'm getting scared after a while because I say if there is only like a need for 10% on what I trusted others in total, I don't mind, but if this is coming to this point, I rather should have an automatic shutdown that I cannot hand out more money. How do you manage that?
Yeah, you could participate in a currency network where that is built in. So you can have there are governance hooks implemented. They can be delegated to, for example, smart contracts where you can have a limit on the amount of credit lines that can be set, or a limit on the total level of credit that can also be given in an individual credit line. So that would be the ideal currency network for you then.
Good thing here is it's hosted on the blockchain, so you always, your smartphone or AI or whatever the algorithms is on your smartphone could check what's going on in the network. You would immediately notice if one of your friends is mostly indebted. Yeah? So then you would reduce the credit line. If he's indebted to you already, you would try to do a debt cancellation transfer so that he's instead indebted to someone else and less to you, and then you reduce the credit line. So there's, because it's on the blockchain, all data is public. You don't know who these persons are except for your direct friends. You have ways to see how the credit worthiness is and how the spending behavior is or indebtedness of the friends is. And if they're very indebted, you'll probably ask them what's wrong, why are you increasing your debt from week to week? Can I help you? Hopefully. Banks would say, I closed your account. So we hope that also the social aspect is more important as now.
Yeah.
So if you want to prevent imbalance through fees, so in a way that if you want to create imbalance, you have to pay more fees, which then, when there's imbalance, right, it would act as an incentive for people who would want to offset that fee, that imbalance in kind of way by lowering the fees. Is that correct? For them?
You're referring to the imbalance fee now?
Yeah.
Yeah. There will basically just be several paths. In a scenario where there will be several paths, the system will take the one, or we will add a fee to the ones that create a higher imbalance. So if we have like one path which creates an imbalance of 20 and one which creates an imbalance or reduces the imbalance to 0, meaning that there's people who owe each other less in that trust line, obviously the other paths that create a higher imbalance would be more expensive. So the system would prioritize the cheaper one in that scenario.
Okay, so but in the way that we get more people like to offset the imbalance as a way of like they don't have to pay fees.
Yeah, exactly. So they don't have to set. What was the last part?
And then it's also like to offset the fees, to offset the imbalance, not charging people fees is like an incentive for that.
Yes. Yeah. Yes?
Could you already analyze if it is possible to apply concepts from Raiden to Trustlines?
Yes, actually Raiden inspired Trustlines and the other way around. In Raiden we have the same setup. There's multiple nodes and we find paths between multiple nodes to payment to those which don't have direct path, and the only difference is in Raiden we use collateralized tokens. So you always can get these tokens on the blockchain, while in Trustlines we use trust relationships. So there's some personal debt relationship between two.
So basically they are compatible.
Yeah. The problem is a bit, in Raiden we assume that these nodes or full nodes, they are always online, so they can help with the routing. But as Trustlines will be based on smartphones, smartphones are mostly sleeping or not on the network or whatever, so they cannot help as intermediaries. Therefore, we're currently first looking into the implementation of that system on the Ethereum blockchain.
Alright, so thank you all for coming. Thank you all for being patient with a little overhead in time. I think the buffet will be open until the end. Where's the end? Well, open and no. Is there a fixed end? Okay, so thanks to the speakers, thanks to PricewaterhouseCoopers for sponsoring, and thanks for the Finance Club for the donation.